Yes, sir.
This is, what is the test called? CMI tomato mock or?
Sir, it's CMI Tomato Mock Test number 1, 2023, full syllabus test.
Okay. Mock test 2023. Okay.
Yes, sir. Full syllabus test.
That's the name of the test? Full syllabus test.
Yeah,
Okay.
full syllabus test. That's all.
Right.
And it's mock test number 1 because I
Right.
think there'll be another one.
Of course. Right. Yeah. Okay.
Yes, sir.
Yeah. So let us try the questions and see.
Yes, sir. So A1, that is objective part 1.
Yeah.
For how many integers A with 1 greater than A less than 100 is A power A a perfect square?
Strictly less than 100?
No,
Because,
inclusive, sir.
okay. But anyways, that doesn't work, I think. Yeah.
Yes. So 1 as well.
Huh. Is A power A perfect square?
Yes, sir.
Okay.
So there are options, but it's pretty standard. 50 even numbers and 5 of the form like perfect power, odd perfect power to the odd perfect power. So like 9 power 9 or 25 to the power 25, something like that.
Hmm.
So
Okay.
50 even. So we have stuff like the form 4 to the power 4, 8 to the power 8, 6 to the power 6. So all these, like, so 50 even numbers.
Hmm.
And then we also have 1 to the power 1, uh, 9 to the power 9, 5 to the power 5, 25 to the power 25, and 49 to the power 49.
Hmm. So
Then
what
6
about
square.
them? But we want perfect squares.
Yeah,
Okay. So these will not work, right?
not 5 to the power 5. So 9 to the power 9.
Right.
Like odd
Sorry. Yeah.
squares.
Yeah.
Like
Correct.
A is equal to odd square.
Right. Yeah. So yeah. So you have numbers like this. Let us write them in the form. And then you are saying, so you have taken care of even numbers, and the other is the odd numbers. Odd, yeah.
Yes, sir.
Odd numbers may they have to be perfect squares. What about odd numbers
Yeah.
which are not perfect squares?
Oh, so we can't have them. If you take something like 5 to the power 5,
Hmm.
like we can't have them. The exponent
Right.
is
Can you
like
give a,
fixed to be.
that's right. That's right. But can you give a reason? Can you give a general, explain it in general? Why?
Okay.
Yeah.
So sir, suppose we have 2k plus 1,
Hmm.
2m plus
2m.
1
Okay. 2m plus 1.
to the power 2m plus 1.
Hmm.
1 second, sir.
Yes.
Uh, okay, yes, sir. So since 2m plus 1 is square free, like we know that. Oh, 1 second.
2m plus 1 is not square free.
Yeah, it's not square
What
free.
is the
But
definition of square free?
it's not divisible by any square. So like,
Okay.
yeah, that's not.
Hmm. Fine.
Uh, I guess, yeah. Okay, so since we have that 2m plus 1 is not a square, we know that every exponent, if we write it as p1, p2, p3, we know that every exponent is odd. So like
Wrong.
in the prime factors.
Wrong. Every exponent is not odd.
Oh,
Every exponent is not even.
oh, right, yeah. Not all are even. Yeah. Sorry.
Right.
Yes, sir.
Not all are even. Right. Okay.
Right. Yeah.
So, right. So let us say that this is odd,
Y-
and then there is some
Yeah.
other d. where GCD of
Yes,
P1
sir.
and D is 1. Okay, then. Or do you, or
So
I'll,
2s
sorry,
plus 1?
one second, sorry. I'll just write the factorization, okay? Because I think, yeah, you have to reason based on your, yeah, the way you are continuing. Okay,
Yes, sir. So now we raise this to the 2m plus 1th power.
right.
So when we do that,
2m
we'll
plus
have that
1th
this.
power.
Yes, sir.
Okay. Mhm.
So when we do that, we'll have that the exponent of P1 is necessarily odd. So there's like at least one odd power.
Right. Okay, correct.
So it's impossible to be a square.
Yes,
Yes.
yes. Okay, this is fine. Utkarsh, yes, so we are doing problem solving today. So there is a certain mock test which we are we are trying, the objective questions of that mock test. Okay. What I suggest to you is that you solve this with us and to begin with, and then we'll see. And also, you should also,
Okay.
yes. And number two, that Aryan can share us the mock test link where he's solving these mock tests from. And you can then try the subjective paper of that mock test also.
Okay, yes, sir.
Right. You can, so it will be very good practice, okay, to do it efficiently and effectively, in a short time and so on. Okay. So do that, but now let's solve this with us quickly.
Yes.
Like small, these are probably small questions. Okay. So now, Aryan, coming to you, this
Yes, sir.
this explanation. So you have noticed that you need to practice these explanations more often, right?
Yeah,
Even
yeah,
when you're
yes, sir.
writing, how elegantly you can write, right? How elegantly you can
Yes,
write,
sir.
how crisply you can write the reasoning. Like for example, once you had also sent me a solution. Last solution you had sent me, it was a it was a simple question, but you may have noticed that your solution was quite long. You may have felt that.
Yeah,
Yeah.
was it like the n factorial ones?
Yes, n factorial one, right? You may have realized later that the
Uh,
solution was quite long, but there was nothing wrong in the solution. That's why, yeah. But you have to just practice
yes, sir.
this. And in an
Yes, sir.
interview or something or an exam, you may have to sometimes even explain more that why all the prime powers have to be even, right? In the prime
Okay,
factorization
yes.
for something to be a perfect square. You may, if you're writing in an exam, you can quote it as a result. You can quote that. But if you're, somewhere in an interview or something, then you have to explain it properly. Okay. If they ask you to
Yes, sir.
especially.
Wait,
And
sir, isn't the answer all even numbers between 1 and 100?
something more. This is what I was also thinking in the first minute or whatever. There are more things
And
as well.
1 to the power 1.
That is there,
Nothing
and
more like that.
no, yes, these numbers will also work. Any odd perfect square also works.
Okay.
And
Yes,
you
right.
can see that, right? Yeah. And then basically we were now it is quite obvious that nothing else works, but we have to prove that, and we were basically proving that nothing else works. Okay, these are all easy things, but to write them efficiently is really very, very important actually. That, yeah. Okay, anyways, let's move on. This is a simple question, and then you can count those things. Let's move
Yes,
to
sir.
question 2.
Uh, so question 2, let A be a non-empty subset of the real numbers and F be a function from A to A
Okay.
such that f of x
Hmm.
is equal to the identity for all A, for all x in A.
For all x in.
Yeah. So then the options are f of x is a bijection, 1 1 but not on 2 but not 1 1, and neither. So
Okay.
it's so
So
those are the options.
let us just ask if fx is a bijection.
Yeah. Is fx a bijection?
So let's just wait for a minute so that Utkarsh can just also think through this,
Yes.
because I suppose he has
Yes.
not seen this question.
I think fx is a bijection.
Okay, so explain, give us reasons.
I just like took fx equals to x,
Okay,
and
that
then
works.
we can get that works this, and fx equals to x like from a to a will be a bijection only.
That's right, that's right. But you know that that's not the complete reasoning.
Yeah, but now we get the answer, right? Like it's an objective question.
Oh no, because there may be some function that is not a bijection and it still satisfies this equation. We have not
Okay,
proved that there is
then
no such function.
like
Yeah. Aryan, can you give us,
no,
or anyone can anyone, okay, let's do this thing first. Can anyone give an
I have one
example?
more thing,
Okay,
an
just one
idea.
just 1 second. So okay, then tell your idea. Yeah.
We substitute x by f of x in this equation.
You cannot do that. You don't know if uh, you do not know if you can do that. Substitute x by fx. Okay. Yeah, sorry, actually you can do that. Yeah, okay.
Then we get f of x is equal to f of x.
But now you should okay, correct. Okay, correct.
And
Sorry.
maybe we could go on to form a recurrence from here.
Okay. So that's an idea. Okay. All right.
Yes.
Okay. But something much simpler may work. Also, can anyone just give me a few examples of functions which satisfy this and they are not the identity function? Quickly.
So one f from r to like r not containing 0 to uh, what is that r? Oh, f of x is equal to 1 over x.
Uh, oh, that's a nice one. Yeah. X
Yes.
goes to 1 over x.
Yes, sir.
No, but then this is not a bijection. This is mostly true, but I suppose you cannot get
Oh,
0.
okay.
Yeah. You have to remove 0 on
Yeah.
both
Right.
sides. Yeah.
Yeah,
This is
I
a,
forgot about that. Yes.
so Utkarsh, you can see this is a bijection. This is an example. Okay. So
This
basically
is a bijection, right?
yeah, this is a bijection, right? Of course. And it's obviously has satisfies this. Okay.
Okay.
Yeah. So I think there is some much simpler will work. So Aryan or anyone, do you have reason why this is a bijection?
Yes. Yes, sir. So first we begin by proving that it's 1, 1.
Yeah. Why is it 1, 1?
So suppose we take two distinct elements, x1 and x2 belonging to A,
Hmm.
such that f of x1 is equal to f of x2.
Hmm.
Then we can apply f on both sides. So we'll get f of x1 is equal to f of x2.
Oh, right.
Yes. So this is a very simple problem,
And
but how useful this can be, you cannot like you can imagine that later. And this can be very, very useful.
Yes.
Right?
And
And so
to prove that it's onto, since we have f of x is equal to x for all x belonging to A,
mhm.
one second. Yeah. Oh, okay. One second.
Yeah. So why is it onto? Onto is actually also as easy.
Right. Yes, sir.
Anyone sees? Utkarsh, do you see why it can be onto?
every, I don't know, like
Hmm.
I can't say that.
Okay, so we can begin by just picking up some random, say y belonging to A.
Hmm.
Then, so we have to prove that y is equal to f of x.
For some
But then,
x.
yes, sir, for some x.
And that
So
x
if we
is just
pick
f of
x,
y.
yeah, if we pick x is equal to f of y, we're done.
Okay, so you can
Yeah.
put, yeah, that's that. It's very simple. Very, very simple. Right.
And
Yes.
we need to prove the other way also, right?
Other way,
That
what?
for every x we have, for every x we have a y also.
But that is just the image. No, that is fx, right? So,
Okay.
right, you have to prove surjectivity. So you want to show that for everything here, there is something here that comes there. That's all, right? That's it. That is enough. Yeah. So these kind of functions are very important. Here we can just check out some general lemmas also, which are very useful. Is something like this. And this I think was also a CMI problem at one point, but never mind, that's not important here. Suppose that f is a function, so maybe we will just say, yeah, no, we just need two sets. Yeah. A and B, wherever they are, it doesn't matter, just two sets A and B. Like here, R was not important, A and B. And now let's say that f is there, and now there is a function g such that f composed with g is equal to identity. Or if you like that other notation, then f of this is equal to x for all x in, what should it be? A.
A,
Right?
right.
Yeah. I mean, obviously, I should mention that this g goes in this direction, but it's clear even from here that x has to be in A. So just from here, can you say anything about f? Can you say it is bijective or it is 1-1 or?
No, so you have given that geo. We have some two sets A and B,
Huh?
and we have g of f of x is equal to identity,
Right.
and we don't know anything else apart from that, do
No,
we?
no, correct. So what can we say about the f from here?
F of x is this thing what we say. No, so f of x is bijective, and so is
Mm,
g of x.
no, no. If you,
Oh wait, not bijective. I should
yeah,
not say bijective. It's onto.
okay, then try to give a reason why is it on to?
Uh,
Yeah,
because both of the sets, like I have it in my mind, but I'm not able. I have not
and
practiced
think about
function.
it. No problem, no problem. Think about it little
Uh,
bit. These are simple. Yeah, think and
1 minute,
then,
sir. Just 1 minute.
yeah. Aryan, you should know this. What can you say about f?
Yes, sir. Even I feel like it's on to. So like I'm trying to.
Okay.
So maybe if you take some y belonging to B,
Hmm.
then since g of I sends it to A, so and g must be defined. So 1 second, sir.
Sir, I want to ask few things, sir. 1 minute. I
Hmm.
just forgot these things. Sir, bijection is both onto and 1 1, right?
Yes.
And then what is a surjection? Like I know surjection and injection, but I forgot what they are.
Yes, I understand. That's
Surjection is
okay.
onto.
Yes. Will the
Surjection
image?
is onto,
Yes.
and injection is
1-1. So
1
two
1.
different things will go to two different things.
Okay, I just forgot those term. They came into
Yeah,
my
that I
mind, right?
understand. Yeah, yeah. Injection and surjection.
So I think f of x is 1, 1.
Okay.
Now, what does 1, 1 mean? 1 minute. I'm getting little bit confused. One
Yes.
minute. Just 1 minute, sir.
Yeah.
1, 1 means. Okay, so like for x, for f this, we can say that we take two distinct elements, x1 and x2 in A,
Right.
and then we say that f of x1 is equal to f of x2.
Right.
Now we put g on both the sides,
Right.
and x1 x2 are not equal. So and we get x1 is equal to x2, which is a contradiction. That means that f is 1, 1.
Right. So F is 1, 1.
Right.
Yeah.
And
So, mhm.
I think g is on 2.
Yes, that
The
reasoning will be
final
same.
is that what Aryan had proved before.
Yes, it's the same question, right? There is no difference in that question and this, in fact, right? In that way.
Okay.
Just give a quick example where F is not onto counter example. Anyone?
Where f is not on 2.
Yeah. So we are not discussing G because we understand the situation for G is just sort of we understand its
So
situation.
we can take
Ah,
oh, 1 second, sir.
yeah.
Oh, no, no, no. I thought I had.
But why do we need a counter example? Can't we just say that for any element, like in the previous case, like how Aryan did, like for any element y, we can't actually say that f exists always. We say like by the information that is given in the question.
But how do you prove that you can't say, right?
Because we have not been given about that information in the question. Nothing apart from g of f of x is x,
Yes,
and
I understand what you're saying, but uh, then it comes down to saying that there is not enough information in the question. But how do you prove such a thing? You have to also prove that, right? That there
So,
is not enough information in the question. Yes.
so we're looking for f that is not onto, just to be clear.
Yes. Yes.
So we can take a and b to be equal to r minus the set containing 0.
Okay.
And f of x is equal to x squared.
Okay.
So this is not on to, because like
But it's also
negative
not
numbers
one
are.
one. It's also not one one.
Oh, so we want f to be 1 1 as well.
Otherwise, you can yeah, I want f to be 1 1. No, I don't want f to be 1 1.
Uh,
If your example has to work, it has to be
Okay.
1 1, right?
All right, right. I
Because
forgot.
that is the part of the question.
Because then G, if G will be root X, it can return two values.
Correct. Yeah, G can return
Wait,
two values. That's a very nice.
no.
That's a very nice point that it can return two values. Right. You can choose one value, but then uh, yeah, yeah. But yes.
Wait, sir, I am not getting that how f of x equals to x square is not working over here.
Okay, because it is not 1 1. Any example has to be 1 1 because we have proved that. Like it's not like I am making the question difficult. No, f is 1 1 is a consequence, and f is not this. F is not 1 1. So this can never
Okay,
work.
so if f is not 1, why are what will happen? If f is not 1, then what will happen?
Okay, then it will not satisfy this equation, right? It will not satisfy this equation, right? We want it to be satisfy this equation.
No, so like we can put g as root x
Okay, no, but see, okay,
and we can still get x.
okay, let us see. So x goes to x square, and you put g as root x, right? So you take this and you take root x, and maybe you want to say that you take positive root or something, right? Because then which root do you choose? You need a function, right? So maybe I'll say that you are
No,
taking
but how
positive.
does it matter? We have not.
But
Sir,
g has to
your
be a
voice is
function.
breaking a little bit.
Okay, is it still breaking?
Yeah, a little bit.
Okay, I
Is
see.
it for only me or for
Yeah, Aryan is
Yeah, yes, sir. Your voice is breaking a bit.
okay. Okay, then I'll just
Yes,
change the
sir. It's
connect.
breaking.
Yeah, change the connection 1 second.
one?
Okay, right. So you see, this example doesn't work.
I'm not telling only to take mod. I'm just telling that we can take root of x square,
No, but
and
root of
still it
but
will.
no, but root of x square is not a number in that case, right?
Oh, it will. Yeah, right.
You don't know what it. You don't know. There are two possibilities, right? There are two things whose
So,
square will be that x square.
so we want x, but we don't want negative x in
This
the.
example will not work. That is the problem because fx equals to x square is not 1 in this domain. This will never work,
Yes,
no matter
sir.
what you do. One can explain that more clearly, but you can understand this clearly violating the 1 condition. See, any example that works has to be 1. It's not 1. This will not work. Okay. Yeah, you can see directly why it's not working. That's a good exercise. But for example, if you take positive, then there's a problem because then you won't get negative numbers. So how will you get? If you take -5, you will never get -5 in the end. So it will not work, and so on. You can understand. But directly you can say it will not work because f has to be 1. So please think of things. This kind of thing is very, very interesting. Where basically f is 1, okay, but uh, f is not onto. Not onto. Can you simply think of a function which is 1 but not onto?
So on its own, we can take f going from set of integers to the set of integers such that f of x is equal to say 5x plus 2.
Okay, why don't you just take x going to 2x?
Oh yeah, okay, yeah, we
Right?
can take that also
So
from natural, yeah, or integers maybe.
from integers to integers, 5x plus 2. Now can you so this f is 1. Now can you make a g for this f? Yeah.
G
1/2
has to be 1
x by
x by
2.
2.
So you have to sort of define it carefully. You say n going to n by 2 if n is even,
Yeah,
but then if n is odd, then you maybe say that n goes to n minus 1 by 2 or something.
yes.
But does this work? Do you get
No,
back?
the range. Sorry, the domain and the range change. Oh, sorry, it works. It works.
It works. Let's check it.
But the only thing is that f will always return an even value. So
No, that is
Yeah,
fine.
so that's why it works. That's why it works actually.
Right. So something like this works. You can just check that g of f is x. Okay. Okay. So let's
Yeah.
just take let's take 5 minutes break maybe, and then we will meet. Okay. Just collect these ideas and then okay.
Yes.
Yeah. Then we'll meet. Just do a recollection, a summary, and you